equator, we have parallel of latitude, we have Greenwich meridian, we have meridian, we have center of the earth, and so on. And I also explained how to find the distance along the parallel of latitude. I explained that latitude is a small circle, except the equator. Equator too is a latitude, but it's a great circle because it passes through the center of the earth. Are you with me now? That's the only latitude that's a great circle. And if you want to find the distance along the parallel of latitude, you use the formula for that length of arc. The length of arc is theta over 360 times 2 pi small r, where that small r is the radius of latitude. And when we now change that radius to big R cos alpha. Are you with me now? So today we want to talk about distances along great circle. When I was explaining some of these features that we have inside this globe, I explained that each longitude is a great circle. Each longitude is a great circle because when you cut an orange like this, you always pass through the center of the earth. But the only latitude that is a great circle, you all know that as what? Equator. Are you with me now? But if it is longitude, we have, let's assume that we have a point here and another one is here. You can see that the 2 points are on the same meridian, and that meridian is a great circle. You can call it meridian, you can call it longitude, it's a great circle. So it means that if I want to find the distance along the great circle, it's going to be theta over 360 times 2 pi bigger. Why is it bigger? That longitude is a great circle. You know, if it is a small circle, we are going to use theta over 360 times 2 pi small r. Where that small r is bigger cos alpha. Is that understood? Now let us now jot this note down. Please quickly write this. Let y be the distance between 2 points. Let y be the distance between 2 points on a great circle. Let y be the distance between 2 points on a great circle. Then y is equals to theta over 360 times 2 pi bigger. I've just explained the reason why it is bigger that I used there. I explained that longitude is a great circle. That longitude is a great circle. That's why the formula now changed to bigger. Because if I ask you to find the distance along the great circle, you now go ahead and use small r. You have already missed it. That substitution there is 0. And once you have m naught, there's no way you can get any mark from that. So you must be sure of the formula to use them. So that's the formula to use when you are trying to find the distance along the great circle. Now let us look at this example. Now example 1. Find the distance between the given pairs. Find the distance between the given pairs of points. Find the distance between the given pairs of points on the surface of the earth. Find the distance between the given pairs of points on the surface of the earth in each of the following. In each of the following. Full stop. In each of the following. Full stop. Give your answer, comma. Give your answer, comma. Correct to 3 significant figures. Correct to 3 significant figures. Now, open the bracket, take pi equals 3.142. Take pi equals 3.142, and radius of the earth, bigger. Radius of the earth bigger equals to 6,400 kilometers. You know, that radius is constant, 6,400 kilometers. Now we have this following point. The first point that we have is capital A equals 20 degree north, 40 degree east. And B, we have 30 degree south and 40 degree east. Then the second question is C equals to 10 degrees south, 15 degree west. And D equals to 45 degrees south, 15 degrees west. Now look at these two questions. I'm going to do only one, then you will do the second. Okay? Now look at what they have. I will start by drawing the diagram for the first one. This is the globe. Let me draw the globe of the board. Now this is the globe now. This is the globe. This is the equator. You show that equator, 0 degree east, 0 degree west. This is North Pole, this is South Pole. Then from this question A, we have 20 degree north. You all know that anything from this equator upward is north. We have 20 degree north, 20 degree north, 40 degree east. This is east. 40 degree east, 40 degree east. And there's a point of intersection. This is the point A. I hope it is clear. Then the second point is 30 degrees south. South is here, is below this equator. 30 degrees south. 30 degrees south, you label it as this, 30 degrees south. The same 40 degrees, you don't need to draw another one. So the same 40 degrees, and where's the point of intersection? This is it. And this point is what? B. Please you locate all these points A and B in the diagram. Then like I said earlier, that longitude is a great circle. The centers of this longitude is the center of the earth. So I have to join both A and B to the center of the earth. You can join A and B to the center of the earth. Now this is the diagram. So you can still see that what we are going to have there is a sector. This is a sector. The diagram is a sector. AOB is a sector. And this one is bigger. Why is it bigger? It touches the center of the head. Why this one too is what? Bigger. It touches the center of the head. That's why the formula now changed to theta over 360 times 2 pi bigger. Then you state your formula. Distance AB, even if you don't want to write distance AB along the parallel of latitude, just write distance AB equals to, along the line of longitude, along the line of longitude. Distance AB, theta over 360 times 2 pi bigger. Why is it bigger? It's a great circle. Then let us first get the angular difference. Let's get the angular difference here. Now to get the angular difference, when I was trying to explain that angular difference yesterday, I said, don't say because we have difference that we are going to subtract. It depends. If you have 2 points on the same pole, that is when you subtract. And I explained the reason behind this. That when you have them on different poles, then you add. For example now, when you place your hands on A and B, look at this. And it is not possible for me now to say you want to get the angular difference and come down. But this is it. When you have 2 points along the parallel of latitude, if you have something like this, along the parallel of latitude, this is equator, let's say this is latitude, we have one here, we have one here. There's a point here, there's a point here. If you place your 2 fingers on it now, for you to get the angular difference, this is it. It is not possible for me now to say, I want to get the angular difference and move towards this side. Are you with me now? So, to get the angular difference is this. It means we are going to use 20 and 30. And we have the 2 on the different poles, and that is what, is it addition or subtraction? Addition. And you can even see that when the thing is here, from here, this is 0. The thing move forward, 20. This one also move down, 30. If you now want to find the distance between the two, it's going to be addition. So angular difference is 20 plus 30, and that is 50. That is 50. And in this one, there's nothing like alpha. There's nothing like alpha in this one. It is only when you have 2 points along the parallel of latitude that we'll be talking about alpha. If it is along the parallel of latitude now, that is when you use small r. And that small r is big R cos alpha. But along the great circle, it is 2 pi bigger. So I don't really need alpha. Although we have a common longitude here. That is 40. So I don't really need that 40. Are you with me now? I don't need that 40. So that's why at times, if you don't have that longitude in the question, maybe you have along the meridian, Along the, you just have meridian, and that value of that meridian is not given. You don't really need that value. So we now have this. So theta now is 50 all over 360 times 2 times. According to the question, what is pi? 3.142, and bigger is 6,400. Now multiply all the numerators together and divide it by 360, and what do we have? 50 times 2 times 3.1, what? 5,585.78 kilometers. Do you have degree of accuracy in that question?
Yes.
And what is that? Just so 3. 1, 2, 3. Who can approximate this answer to 3 significant figures for us? If you know it, raise up your hand. Okay. 5,509. Please clap for her. It is 5,519. Let's round it up and get 559. It's far from the original number. So that is 5590 kilometers to 3 significant figures. In fact, there's no need to write the approximately to 3. You are less concerned about that. Just write 5590 kilometers. That's all. Is that taken? Yes, now, is there any question on this before I ask you to solve the second question? So let me give you just 5 minutes to solve that question. Then I can call on any one of you to come and solve it for us on the board. So yeah, the time starts now. So I believe you all know the reason why we always put dot there. You cannot see the line at the back. I mean, are you with me now? So that's the reason of putting dot. 15 west. Okay, 45 degrees south. You didn't label your points. The second point, you only have C there. Okay, that's D, okay. Wow. Okay, you want to get the angular difference, okay? Okay. Now, I've told you several times that when you are writing the formula, don't just write ordinarily the formula. Distance CD is equals to. It is possible to have that distance. Okay, when you have the distance, if you don't write distance equals to, you'll not be able to do the substitution. When you have for multiply, you can ask your student to multiply for you now. What? Which 10? Is it 15 that we have there?
10 south.
10 south, 45 south. Let her continue. Let her finish first. Oh yeah, I'm help. 4, 4. Please dictate it one by one for 1, 4. Okay, 0, 7. 1, 4, 0, 7, 6, 1, 6. All over 360. Oh yeah, what's the final answer? Please talk. 3910. 0.004 kilometers. Now approximate that answer to 3 significant figures. 3910. Is it the final answer?
Yes, sir.
Please clap for her. Thank you. But look at the diagram. Something I want to say here. This is bigger. This is bigger. So this is not the center of the earth. Center of the earth is here. Okay? So it's supposed to join this to this. And this one to this. Not to the circumference. Because this is circumference. Are you with me now? To the center. That's the only thing that is wrong there. Is that taken? So let us continue. Example 2. So that longitude, it is line of longitude. Because all these longitude, they are not parallel. Am I communicating? You all know what I mean by parallel lines. Two lines that will never meet. Because they will be keeping the same distance all through. So line of longitude for parallel of latitude. Because if someone just tell you that it is parallel of longitude, there's nothing like parallel of longitude for line of longitude. So in this question, let me go back to that. We have two places are 264 kilometers apart on the same line of longitude. Now that you have the 2 points on the same line of longitude, and that longitude is a gray circle, that determines the formula you are going to use there. So it's going to be theta over 360 times 2 pi half. And what is the distance that is given in the question? 264. You can see what I'm saying here, that if you fail to write this distance, maybe you just put theta over 360 times 2 pi half. Where do you want to put that 264? So 264 is equals to theta over 360 times 2 times, let me use 20 over 7 times 6,400. Now if you go back to that question, you will see that what we are asked to calculate there is difference between their latitude, and that is what? Angular difference, and that is theta. Okay, that is theta. So with this, we can now solve it. 264 is equals to the product of 360, and 7 is what? And what about 2 times 22 times 6,400?
281.
281.
600.
600 theta. 600 theta. Then what's the next thing to do? You cross multiply. 264 times 2520 is equals to 281 600 theta. What is the product? What is the product here? What is it? 665 280. Okay? Is equals to 281 600 theta. If I put out like this, 665 280 all over 281 600 equals to what? Theta. What is theta now? 2.36, that's 2.4 degree. 2.4 degree is the angular difference. 2.4 degree is the angular difference. Two places X and Y on the equator. Two places X and Y on the equator are on longitude 67 degree east. Two places X and Y on the equator are on longitude 67 degree east and 123 degree east. 67 degree east and 123 degree east, respectively. Full stop. Question A. What is the distance between them along the equator? What is the distance between them along the equator? What is the distance between them along the equator? Question B. How far is X from the North Pole? How far is X from the North Pole? Question mark. How far is X from the North Pole? Question mark. Take another line. Open the brackets. Take pi equals 22 over 7. And the radius of the Earth. And the radius of the Earth as 6,400 kilometers. Close the bracket. Drawing the diagram. This is the, let me draw the globe on the board. Let me draw the globe on the board. You have this. So we have these as polar axis. We have these as equator, north, south, 0 degree east, and we have 0 degree west. Now, in the question, we have 2 places, X and Y, on the equator. You already have equator on the diagram, Abby? Okay. Then 67 degree east. 67 degree east. This is east. 67 degree east. 67 degrees, this is point X. Okay? And 123 degree east again. 123 degree east. 123 degrees. 123 degrees, and this is point Y on the equator. Okay? Now, the first question is to find what is the distance between them along the equator? What is the distance? Distance between distance, I can say distance xy. But my question is this: if you know it, raise up your hand. Which formula are we going to use? It is theta over 360 times 2 pi small r, or theta over 360 times 2 pi big R. If you know it, raise up your hand. It's a latitude. Okay, look at this now. If I use distance equals to theta over 360 times 2 pi small r, where small r equals to theta over 360 times 2 pi big R cos alpha. Then we have theta over 360 times 2 pi big R cos alpha is 0 and cos 0 is 1. When you multiply 1 by 2 pi r, it will still go back to 2 pi r. So I can use small r because it's a latitude. I can use big R because it's a gray circle. Am I communicating? Okay, so that is that. So with this, we can now find the distance. But before we can find the distance, let us get the angular difference. Angular difference is this. X and Y, this. And we have them on the same pole. 123 minus 67, and what is that? What is that? 56. 56. Okay, so let me now state the formula according to that girl from AGGS. 360 times 2 pi big R. So we now have theta as what? Theta as 56 all over 360 times 2. What is pi? Okay, is it 22 over 7?
Yes, sir.
22 over 7. What is big R? 6,400. So 360 times 7 is always 2520. That's 2,520. Then what is the product of 56 times 2 times 22 times 6,400? Let me press it. 1576 00. Now divide. 625 7.8 kilometer. There's no degree of accuracy in the question. Having? Do we have a degree of accuracy? Let's leave it. 6,257.78 kilometer. So that is the distance between X and Y on the great circle or on the equator. As I say, on the great circle, on the equator. Are you with me now? So that is that. That is the first question A. Then the second question is distance. What is the which formula are we going to use? How far is X from the North Pole? Which formula are we going to use? If you know it, please help. Anybody? No idea? No idea. Okay, now listen. Now look let's go back to the diagram. You are the one that will tell me the formula to this now. And what is that? North point is 90 degree north. Now I told you that the highest one from 0 to the highest one is 90. From here to is 90. But for longitude, it's always 180. If it is 180 degrees, that's the highest one. 180 degree west. So when you now add the two together, to give you 360. So if it is 90, you want to find the distance between X and the North Pole. Look at this. Now the two of them are on what? The same
Longitude.
Longitude. And that longitude, is it a small sample or great sample?
Great sample.
And which formula are we going to use there?
2 pi.
Theta over 360 times 2 pi.
Bigger.
Why is it bigger?
Great sample.
It's a great sample. It's a great sample. So it means that the formula is, so let me use this. Okay, distance between X and North Pole is equals to theta over 360 times 2 pi bigger. You already know the reason why it is bigger. But what is the angular difference? What is the angular difference between X and North Pole? Why is it 90? Is it subtraction? Whether it is 90 minus 0 or 90 plus 0, we are still going to have 90 degrees. Then you do the substitution. 90 all over 360 times 2 times 22 over 7 times 6,400. Now, the product of 360 and 7 is 2520. 90 times 2 times 22 times 6,400. 2534 400. How many zeros? 3. Okay, divide. 57.14 kilometers. So you guys say the thing is very simple. Is it difficult? It's very simple. Degree naught, n degree naught, 0 degree, and W 27 degrees south, 0 degree. Point Z, n degree north, 0 degree, and W 27 degrees south, 0 degree. Lie on the Greenwich meridian. Lie on the Greenwich meridian. Lie, L-I-E. Lie on the Greenwich meridian. Full stop. If Z is 8,000 kilometers from the North Pole, if Z is 8,000 kilometers from the North Pole, comma, calculate column. Calculate column, okay, question A. Calculate column, question A. The value of n to the nearest integer. The value of n to the nearest integer. The value of n to the nearest integer. B. The distance ZW. The distance ZW along the Greenwich meridian. Along the Greenwich meridian. The distance ZW along the Greenwich meridian. The distance ZW along the Greenwich meridian. Full stop. Open the bracket. Take another line and open the bracket. Use the values. Use the values 3.14. 3.14 for pi. For pi. And 6,400 kilometers. And 6,400 kilometers for the radius of the Earth. I said use the values 3.14 for pi and 6,400 kilometers for the radius of the Earth. That is big R. Now let us interpret this question. Now we have a globe. This is the globe. Polar axis. We have equator. North, south, 0 degree east, 0 degree west. Now look at this point. Look at this point. Although the value of that n is not given, but we have north. It means that it is on this pole. Now we have it as this. This is n degree north. Despite the fact that the value of that n is unknown. Then when you have this is Greenwich meridian. If you have it as this, if you have 0 degree, 40 degree east, if you have 0 degree here, this is equator. If you have it here, that is Greenwich meridian. Take note of that. Now, 0 degree, I can put it here. I can put it here. We have it, we have this 0 degree here. We can also have it at the back too. Are you, because from this globe, when you take this as Greenwich meridian, this one that I'm holding here, when you take it as Greenwich meridian, we also have another one here. You know, the thing is a circle, Abi. So the circle is moving like this. So we have another Greenwich meridian. That's why I said you can have it here, you can have it here. Is that taking? So even there's no need to label it because we don't really need that Greenwich meridian thing. Now we have this one as Z. Then W is 27 degrees south. This is South Pole, 27 degrees south. And 0 degree also, this is what? W. Now, the center of this longitude is the center of the Earth. 0, we have this, we have this. This is bigger, this is bigger. Now, what is the first question? Well, okay, the question continues. If Z is 8,000 kilometers from the North Pole, North Pole is 90, and the distance between Z and North Pole is 8,000. I've just explained that if the two of them lie on this line, that is a great circle. Abi? Yes, that's a longitude, and it means that distance, let's say NZ, that is North Pole and there's the point Z, Abi? NZ equals to theta over 360. Is it small r times 2 pi small r or bigger?
Bigger.
Bigger. Why is it bigger? It's a great circle. So you must know the reason behind this. So, and this NZ is 8,000 in the question, right? We have angular difference. Let me go back. Now, let me get the angular difference here. I want to get the angular difference. The angular difference is this. Abi, is it, what is the angular difference in terms of n? Is it 90 minus n or 90 plus n? You know, if you know it, raise up your hand. I don't want to go there. Please sit now, look at the diagram. Okay. 90 minus n. Please clap for her. It's 90 minus n. Because we have that n also on the North Pole. 92 is 90 degree north. So the two of them are on the North Pole. So we are going to subtract. So angular difference is 90 degree minus n all over 360 times 2 times, what is pi in that was 3.14. 3.14 times 6,400. So we cross multiply. 8,000 is equals to 8,000 times 360 is equals to 90 minus n times, what is the product of 2 times 3.14 times 6,400? 40,000. 192. There's no point, right? What is the product of 8,000 times 360? 2,888,800. Something like this, I mean. 288,000. Okay, 880,000. 880. Okay, 0. That's 880,000, Abi.
Yes.
What's the last 3 digits? 000. Okay? Is it okay? Equals to 90 minus n times 40192. Now divide. 288,000 all over 40192 is equals to 90 minus n. What is it?
71.6.
71.6 equals to 90 minus n. So if it is 71.6, let me make n the subject. N is equals to 90 degree minus 71.6. What do we have?
18.3.
18 point, is it 0.3 or 0.4? 18.4 degree north. But according to the question, now we should approximate our answer to the nearest integer. Integer is an whole number. Now what is that? 18 degree. Is that taken? So if it is 18 degree north, so we can now come here and write 18 degree north. That is n. Now, you are going to do this one for me as class work. After getting this n, let's take that n as 18 degree north. Then we now want to find distance ZW. That's question B, Abi. Yeah. Distance ZW is equals to theta over 360 times 2 pi. Now look at this ZW. This ZW, they are on the same what? Longitude. And that longitude is a gray circle. And the formula is going to be 2 pi bigger. And what will be the angular difference?
27.
Is it plus or minus? Somebody said minus. Who is that person? We have this. Look at this. Z, W, north, south. It's addition. Abi, look at this from here now. If this one is 0, this one move forward, upward by 18. This one move downward by 27. And you're still saying it's subtraction. No, it is addition. So that is 18 plus 27, and that's 45. 45, that's 45 all over 360 times 2 times 0.14 times 6,400. Now multiply and divide. What do we have? 5,024. There's no point. Kilometer. That's the answer. Is that taken? The question is this. Two places A and B. Two places A and B on the Earth surface. Two places A and B on the Earth surface. Two places A and B on the Earth surface lie on the same meridian. Lie on the same meridian. Lie on the same meridian and half latitude of 75 degree north, 75 degree north, and 15 degree north respectively. 75 degree north and 15 degree north respectively. Full stop. Find their distance apart. Find their distance apart measured along the meridian. Find their distance apart measured along the meridian. Measured along the meridian. Now number 2. Number 2. Find the distance, comma, measured along a meridian of the South Pole. Of the South Pole from any point on the parallel of latitude. From any point on the parallel of latitude 65 degrees south.